This is the Levin Furniture Senior Project entitled Workforce Schedule Reconstruction for Levin Furniture. The members of our group are Jocelyn Dansey, Melissa Morello, Tyler Rybarczyk, and Nicolas Sunderland. Levin Furniture has been family-owned and operated since 1920. With regional locations in the Pittsburgh and Cleveland markets, there are a total of 30 retail locations, including 14 furniture stores and 16 mattress stores. Levin is operated from their single warehouse and corporate offices in Smithton, PA, and they have around 800 employees. Levin's problem lies within their delivery operations. Their delivery teams are scheduled for up to 10.5 hours a day, usually starting around 6 a.m. Currently, the teams operate at 90 to 100% capacity on average. That results in little flexibility for the 400 to 500% spikes in demand that occur on and after their 9 promotional and holiday sales every year. The current operational model of 5 delivery days a week cannot handle this increase in demand, so our opportunity lies within increasing annual capacity by reconfiguring their working schedule. It was determined that this problem would benefit by the use of 2 newly made analytical tools. The capacity analysis factors in the number of working days per week, the scheduled hours per day, and the number of trucks making deliveries on any given day. The What If tool helps us see how manipulating these factors increases or decreases the annual demand capacity compared to Levin's current model based on user inputs. These tools were based off of the data provided by Levin. In our analysis, we were able to consider associate salary that was based off of a given commission rate, the average number of scheduled versus fulfilled orders per day, and the average time per delivered orders, as well as the annual demand breakdown.
Using the data from the previous slide, we wanted to conduct 2 methods of analysis, the first being the what-if analysis. This was done on a weekly basis for 1 year. We wanted to see the impact on the daily hourly capacity, retail value of the truck, and backlog would be if the number of operating days changed, as well as the number of operating hours per day. This tool will also help Levin to easily calculate potential changes. The second tool is a capacity analysis. By changing the number of operating days per week and the number of operating hours per day, we are able to see how many orders can be fulfilled for the year. This tool calculates the capacity increase from the original 5-day, 10.5-hour annual order capacity of about 161,000 orders per year. In our analysis, we used 3 metrics, the first being an average of the backlog to determine the number of days out. This is an important metric because when orders for the day are not fulfilled, they are rolled over to the next day. The backlog will only keep increasing if the capacity is not changed. The second metric is cost changes for Levin. If more hours are required for delivery teams, then their wages will also increase. The third metric is an average and standard deviation of the daily hourly capacity of workers. An increase in capacity results in more flexibility with worker utilization. All 3 of these metrics are calculated in the what-if analysis. From the what-if analysis and capacity analysis, we calculated the following table of results. We calculated the changes in the metrics when the operating days were 6, 7, and 5-day week, 7-day flex schedules. The 5-day week, 7-day flex involves working 5 days per week during the year and 7 days per week during the 9 promotional holiday sales at Levin. We also wanted to investigate the hours per day at 9, 9.5, 10, 10.5, 11, and an 11.5 hours per day. Based on these findings, when the number of hours per week is increased, the annual cost increases, capacity increases, and backlog decreases. Based on these results, we then needed to investigate an implementation model for each option to then determine which operating model should be chosen for our final solution.
This is what the current schedule looks like. As you can see, the 5-day schedule runs Tuesday to Saturday for the delivery team, whereas the warehouse team will work Monday through Friday. Here's an example of what the 6-day model would end up looking like. As you can see, we extended the work week from Monday to Saturday. This kept Sunday off, which we felt would appeal to more people. Here's the 7-day model, and as you can see, it looks fairly intimidating as every day is filled up. But individually, each worker will not have to work on every day. They will be scheduled in this type of rotational plan. Here's a flex schedule model which is built around bumping up number of work days during national holidays or promotional days. And as you can see, the days are added after the holiday or promotional day to alleviate the stress from the demand spike. Here's the measure improvement we received through calculations. As you can see, the 5-day is the original with a large amount of backlog, whereas 6 and 7-day both reduced backlog to below zero but cost a large sum of money. 7-day flex is where the days are added around the national holidays or the promotional days, and the backlog is reduced a great amount, and although the cost is not much more than the original.
Here we see a graphical representation of the measured improvement throughout the different systems that we set up. There are clear trade-offs with each option, as can be seen by each of the graphs. For example, the 7-hour day will yield the highest capacity, yet cost the company the most, throughout any hours that we choose. Backlog is almost non-existent in the 7-day work week. However, we see the biggest changes in the 5-day, 7-day flex plan for backlog. Our final recommendation for the implementation plan is the 5-day, 7-day flex work week. This will emphasize the work days that are the highest capacity throughout the system, yet still allow employees to usually work 5 days a week. We chose the 11-hour workday as the optimal workday plan because it offers statistically the highest capacity change, the lowest annual cost percentage change over the course of the day, and also the backlogs drop the highest percentage between 10.5 and 11. Finally, we'd like to give a thank you and acknowledgments to Ward, Paula, Joe, and Jean, who helped us along the way from Levin Furniture. We'd also like to thank Dr. Sakari for guiding us along the right path throughout this whole process. Thank you very much.